here is the set of complex numbers. When we were looking for zeros of polynomial functions, we realized that some zeros could be rational numbers, and sometimes they could be irrational. Rational zeros and irrational zeros are both visible in the graph. When we graph the function, we are going to see these kinds of zeros on the graph. But there are times that the zero that we obtain are not visible in the graph, and those are the imaginary numbers. Imaginary numbers result when we have a negative inside a square root. So now let us find the zeros of some polynomial functions. Okay. So here, let's find all the zeros of the function graphed below. And then we're going to write the function in factored form. Well, this function is, this graph is for the function f of x equals x to the fifth minus 2x to the fourth minus 10x cubed plus 38x squared minus 63x plus 36. Since the degree is 5, we know that there should be 5 zeros. Now the graph helps us determine what the zeros are. So the graph gives us already 3 zeros. One of them is here, and another one here, and another one here. So we can visibly see 3 zeros in the graph. So if this is -5, this must be -4. This is 1, and this is 3. So that means that there are 2 zeros that are not shown in the graph, or that they're not visible in the graph. So to write this in factored form, we have to find all zeros. Okay, so let's do that. Okay, so we'll have the coefficients: 1, -2, -10, 38, -63, and 36. Okay. So now we can put -4 because we know -4 is a zero. So we bring down 1, -4, -6. -6 times 4 is 24. Positive 14. 14 times -4 is -56. -56 plus 38 is 18. Negative, so that's negative. Okay. -18 times -4 is positive 72. And 72 minus 63 is positive 9. 9 times -4 is -36. Therefore, we'll have here 0. Okay. So now we are going to look for the next 0 in the graph, which is 1. So we can put here 1. It doesn't have to be in this order. You can start with 3, 1, -4, or 1, any order. We can do this in any order. So we bring down 1. 1 times 1 is 1. negative 1, no, negative 6 plus 1 is negative 5. Negative 5 times 1 is negative 5. 14 minus 5 is 9. 9 times 1 is 9. Negative 18 plus 9 is negative 9. Negative 9. Therefore, we get 0 here. Then we'll put here 3. So we bring down 1. 1 times 3 is 3. Negative 5 plus 3 is negative 2. Negative 2 times 3 is negative 6. 9 minus 6 is 3. 3 times 3 is 9. And we get a 0. So these are the 3 zeros that are visible in the graph. Now we're looking for the last 2 zeros, and because we don't see them in the graph, we cannot use synthetic division anymore for that. But fortunately, since we're looking for the last 2 zeros, we can apply the quadratic formula. So we're gonna start here with the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So here x equals, we plug in, so I'm going to put negative of b plus or minus square root of squared minus 4 all over 2 times, and then there's a there. So, and here's our value for a. So a is 1, your b is negative 2, and c is 3. So we're going to plug it in here. B is negative 2. So here is B again. So that's negative 2. Then here it's A, which is 1. And C is 3. And A is 1. So now we'll have X equals negative of negative 2 is positive 2 plus or minus square root of 4 minus 12 all over 2. So we'll have x equals 2 plus or minus square root of negative 8 over 2. Now, we're going to simplify this. We'll have x equals 2 plus or minus, well, square root of negative 8, let's just do it here on the side. Square root of negative 8 can be expressed as square root of negative 1 times square root of 8. Now, square root of negative 1 is equal to I. So that's just the imaginary unit. So now, square root of 8 is 2 square root of 2. Okay, so we have to break down, make a tree, and then simplify. So now this is 2i square root of 2. Okay, so now for square root of negative 8, we are going to replace this by 2i square root of 2 all over 2. So now we can simplify by dividing each of the expression on the numerator by the denominator 2. So we'll have 2 over 2 plus or minus 2I square root of 2 over 2. And then finally we'll have, 2 divided by 2 is 1 plus or minus 2 divided by 2 gives us 1, and then times I square root of 2. So I square root of 2. Okay, so now we found the last two zeros of f of x. So here are the 3 rational zeros, and these 2 zeros right here are imaginary zeros. So now let's write f of x in factored form. We can put it here. F of x is equal to, so for negative 4 as a 0, the factor will be x plus 4, or x minus negative 4. Then when the 0 is 1, the factor is x minus 1. And when the 0 is 3, the factor is x minus 3. Now for the last factor, we don't want to use these because then it's going to be a little messy. So we're just going to use these coefficients for a quadratic factor. So this will be 1x squared minus 2x plus 3.